Alright, let's focus now on math. We don't really care what other subjects we have. Right now our focus is on the best subject, and that is math. So, we are looking at problem number 1. And it says f of x equals 1 over x plus 3. And the reason that I'm doing this is because I want you to understand, first of all, how much you already know, and second of all, what those directions mean. Okay? Now, way long time ago, we talked about domain. And we talked about the domain of this function would be what? Tan equal -3. Now, in this section, we're going to actually start graphing that. So what that means is you have a vertical asymptote. Remember, we talked about that. Now we're going to finish the graphs. Remember, you had to tell me the vertical asymptotes and stuff? Well, now we know there's a vertical asymptote at -3. The domain is everything except -3. Now, I want you to plot 2 points on either side of this asymptote. 2 points on either side. So I'll put -2 into my equation. What do I get if I put in -2? Oh, come on now. This one. I get 1. So -2 gives me 1. Now I'm going to put in -1. What do I get if I put in -1?
2. -1 for x.
I put in -1 for x. 1/2.
Oh, yeah.
Now, the question says, describe the end behavior at the undefined values, or something like that. I'm paraphrasing maybe. What that means is, as the curve approaches the asymptote, what is it doing?
Never touch it.
Well, it will never touch it, but which direction is it going? Up. Boys and girls, as you approach an asymptote, you have 2 choices. You either go up, you go down, or you have a fatal collision. Those are not allowed. So we're going to go up, or we're going to go down. If I plot 2 points over here, will that tell me which direction I'm going?
Yes.
Now, kids always say to me, but Mrs. Ford, they're going down. Remember, we're talking about what they do as you approach the asymptote. So we would say the limit as x approaches -3 from the positive side. We're coming at this is -3. We're coming toward -3 from the positive side. What's the limit of the function?
3 to infinity.
Where's it going? Positive infinity. Your job is to describe the behavior of the curve as it approaches its asymptote. So what this tells me is, as I approach the asymptote from the right, my pencil goes up. This is the math language for, as I approach from the right, I go up. Now, what happens on the other side? Let's put in, let's see, -4. What do you get if you put in -4? -1. What do you get if you put in -5? -1/2. So as I'm getting closer to the asymptote, what is my pencil doing? Going down. So the limit of the function as x approaches -3 from the left side is -infinity. So when the problem says, describe, whatever it says,
It says use limits.
use limit notation to describe the behavior of the function at values not in its domain. Well, what's the only value in its domain? -3. So we're telling what happens as we approach -3. Okay, so that's what those directions mean. Notice that in problems 3 and 4, you're going to have double the work. Why will you have double the work in problems 3 and 4? Well, there's 2 asymptotes, right? So you'll have to describe what happens to the one from both sides, and then to the other one from both sides. And how did I figure out? I just plotted points, right? Anytime I have a question about a graph, I can plot points if that's what I need to do. All right, now we're going to go down to number 7, and we're actually going to sketch it. We're actually going to complete the graph. We're going to sketch this whole thing. A lot of it you already know. tell me what you already know. This is problem 7. Tell me what you already know about it based on things we've talked about in the past. X can't be -3, so we have a vertical asymptote at x equals -3. Tell me what else you know from back a couple months ago.
Is there
Eli?
a horizontal asymptote?
There is a horizontal asymptote. Where is it? 2. There's a horizontal asymptote at 2. Now, Eli remembers. Do you remember that whole conversation about finding a horizontal asymptote?
Oh, yeah.
Oh, yeah. Does this thing have any holes? No, why not? How do you know? Nothing cancels. Remember, as the problems get bigger, you might have some cancels, some factoring and canceling to do. And if you can cancel, you'll have a hole, but we don't have one. That's old news. We talked about that before. You didn't have to draw it before, but remember you had to list the vertical asymptotes, the horizontal asymptotes, and the holes. Remember that? Now you're putting them in the picture. All right, what else goes in the picture? Well, we have to put in our X-intercepts and our Y-intercept. Okay? Now, what do we know about any intercept? Any intercept anywhere has one coordinate that is 0, right? That's why it's an intercept. So if you are an X-intercept, your Y coordinate is 0, and if you are a Y-intercept, your X coordinate is 0, right? Think about where they are on the graph. Okay, so let's find our X-intercept. This one only has 1. Sometimes they have more than 1, but this one only has 1. If we want to find our X-intercept, we have to let Y be 0. So 0 equals 2x minus 1 over x plus 3. All right, how do we solve that? Multiply by x plus 3, and of course that's 0, so isn't it just going to say this? Add 1, divide by 2, so x is 1/2. You have an X-intercept at 1/2, comma 0. Now we'll find our Y-intercept by letting x be 0. So what do you get when you plug x in there? Negative 1/3. Does that help at all? Do you have any idea what this picture looks like? At least this part of it, hopefully, yeah, it's looking like that. And what's it do out this way? Goes up, but remember, it's got a ceiling, right? It's got a horizontal asymptote. So it's approaching its asymptotes. Okay, that's good. What about this side of the picture? All this space out here, what are we going to put out there?
So we're going to plug in the negative number before it's...
Okay, Brenton says, I don't know what's going on out there. So I'm going to plot myself a point, 2 points, 3 points, however many it takes to figure it out. Great. But you know what? You can use some logic, too. I know whatever happens out here, I cannot cross this axis. Because if I were going to cross this axis, what would I have? Another intercept, and there's only one. So I can't cross this axis. So that means it has to look like this. I don't have a choice. It has to look like that. The only 2 options out here, Brenton, would be what it is, and then this shape right here. And it can't be this shape because it can't cross the axis, except in the 2 points where I've said it could cross. I already plotted those. That's why I always have you plot those first, and then you know exactly where you cross. Curves will always approach their asymptotes. So you're not going to have something going out like this. That isn't going to happen. It's going to hug its asymptotes as it goes off the page. So as it goes up, it's going to get closer to that one. As it goes left, it's going to get closer to that one every time. What is this a version of? Which are your BFFs? That's the reciprocal function, right? We shifted it. That's what happens when you have x plus 3, you shift 3 units to the left. And then when you times by 2, you stretch everything 2 times, and that popped up that asymptote for you. Okay, well that wasn't too bad. Let's try another one. I have a whole bunch here. Let's try number 27. It is a tougher problem. We're looking at number 27 now, on the same page. 27. In order to graph it, the only required things are the asymptotes, holes, and intercepts. Everything else is, if you want to be like Brenton and plot points, go for it. Absolutely, you can plot points. All right, so tell me what you know.
Oh, that's how we can factor.
I don't know, can it?
For the bottom one, can
The bottom one for sure
So
can.
you'll have a hole.
Well, we don't have a hole unless something cancels. So I gotta see if the top factors. I don't know, something tells me it doesn't, but. I'd have to have a 2 and a 1. And that won't work. And 2 and 1 here won't work. I don't think that factors, does it? So that doesn't factor. All right, that's okay. Now, all that means is I'm not going to have any holes. Okay, no holes. Do I have any asymptotes? I have 2 vertical asymptotes. One of them is at -1, x equals -1, and x equals +1. Notice how I'm labeling. You are expected to do that too. I'll be grading your graph, so I need to see it labeled. Oh, Clark, Mrs. Kohler brought this in earlier today and said you might need it for yesterday.
Oh, yeah.
Okay? All right, tell me about anything else you see.
There's a vertical asymptote too.
A horizontal asymptote at 2. Does everybody see that? Horizontal asymptote at 2. Right here. All right, how about some intercepts? The Y-intercept is always the easiest. How do we find the Y-intercept?
Plug in 0.
Plug in 0. And what happens when I plug in 0?
Get 2.
I get 2. Kind of a freakish thing, isn't it? I got a 2 sitting right on, or a dot sitting right on top of my horizontal asymptote. Guess what? That's okay. You're never going to put a dot on a vertical one because those are the undefined. But you can cross your horizontal asymptote. There are curves that actually do something like this around their asymptotes. This one doesn't. But there are things that do that, so don't let that bother you. That's perfectly okay. That is perfectly okay. All right, now what about the X-Intercepts?
Plug 0 in for Y.
Plug 0 in for Y, so that's going to take a little room over here.
2x squared.
Because now I got to solve the equation 0 equals 2x squared plus x minus 2 over x squared minus 1. So I'll multiply by my denominator, but since that's 0, it just stays fine. And we already tried to factor that, didn't we? And it didn't work. So we're going to have to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So where are these roots? X equals, what is that, 17?
Yeah.
I where to plot that, so I'm gonna have to get my calculator out. If it would ever happen to you that you didn't have access to a calculator, can you approximate Root 17? What is it about? It's about 4, a little more than 4. So if you had to do it without a calculator, you could. But we have a long period. It's going to be exhausting. We're not going to wear ourselves out. We're just going to go ahead and do it on the calculator. And I did that wrong. Maybe I should have just done it right here. Okay, so I got about 0.8 for one of them. And about negative 1.3 for the other one. And that's close enough. Remember, we're just doing a sketch. So 0.8 would be about right here. And negative 1.3 would be about right here. So that's where I cross the x-axis. The only places I'm allowed to cross the x-axis are here and here. That should tell you something about this piece of the graph. Any idea what this piece of the graph looks like? If you can't touch the x-axis, the graph must be up here. So it's gonna be one of these guys. That's how they act. They follow their asymptotes. They're shaped by their asymptotes. Any idea at all what's going on in this section of the graph, Dylan?
Would it be like almost like a little parabola, or?
You mean like this maybe?
Yeah.
Okay, no. That's a good idea. That can happen, but not this time, because what would have to happen if it were a parabola?
Oh, we keep going outward.
Well, no, it can follow its asymptotes, but what would happen right here?
Oh, it would need a point.
It would need a point, and I don't have one. Well, if this can't come down, it has to go up, right? It has to go up if it can't come down.
How's it supposed to go?
Yes.
What happens here then? Don't these have to be connected?
Oh, it's about to.
Huh?
Looks like
Yeah, it's gonna have a cubey shape to it. Yeah, it sure is. It's gonna look just like that. Now, we did that from logic. Okay, I'm Brenton. I don't want to do logic. What's Brenton gonna do? He's gonna plot some points. And he's gonna plot as many as it takes him to figure out what the shape is. Anybody have an idea what happens out here? That's what happens out here. You gotta contain that point. It's gotta approach its asymptotes. There you go. Jade?
So, I don't know if this is a smart question necessarily, but up there on like this, the right side, why wouldn't it be going down? No, on the right side.
Here?
Yeah.
Okay. It can't go down because what happens if it goes down?
It crosses.
Yes. Remember, the reason you plot your intercepts is those are the only places you can cross the axis. So whatever shape you're thinking about, if it crosses the axis, it's wrong.
Yeah.
Okay, if you don't have a point.
Can we do another example?
Yes, we'll do another example. Okay. Let's try another one. All right, what about this one? This is not in your book. I made this one up. So in order to sketch this now, the only required things are your asymptotes, holes, and intercepts. Any other points you want to put on is fine. Those are up to you. But we got to start with the asymptotes, intercepts, and holes. All right. So with that in mind, tell me something.
You can have holes.
Well, I could have a hole. I don't know that I have a hole yet, because what do I have to do first?
You do
Factor. So, does it factor?
Yes.
There's the top. And there's the bottom. And there is a hole. There's a hole where?
At -2.
At -2. So I need to plot that point, which means I have to figure out my y coordinate so I know where to put the point.
Plug in -2.
So I plug in -2, and when I plug it into my new problem. This is my new problem now. Right? Because I canceled the rest of it out. So here we go. What do I get if I put -2 in there?
You get 2.
I get -3 over -6. 1/2. So I have a hole at the point negative, isn't it 1/2?
Yeah.
Oh,
-2 comma 1/2.
yes.
So I plot that now on my graph as a little open circle at the point -2 comma 1/2. Now for everything else, I want you looking at this right here, okay? Look right here. So tell me, what else do we have?
Vertical asymptote.
We have a vertical asymptote at x equals 4. Let me erase my equation. The vertical asymptote at x equals 4. Tell me what else I have. I have a horizontal asymptote. Where is it? X minus 1 over x minus 4. So I have a horizontal asymptote at 1. Everybody okay with that? Tell me what else I have that's mandatory information. Well, where are those intercepts? Let's get those intercepts on there. How do I find the intercepts again?
Plug in 0.
Plug in 0 for each letter, one at a time. X is always, it's always easiest to find the y-intercept. If we let x be 0, y is
1/4.
1/4. So there's my y-intercept. All right, how do I find my x-intercept? That's really important. I need to know where I cross the x-axis.
X equals 1.
So 0 equals x minus 1 over x minus 4. So 0 equals x minus 1. And x equals 1.
How do you get rid of the bottom though?
You multiply it over to here. Multiply both sides by x minus 4. What's 0 times x minus 4?
Oh, 0.
So then do we already know that the one in the right corner, top right corner is going to go like
Rankin says, I already know this. I've only done 3 examples and I already have that figured out. It can't do anything else because it can't touch this line and it can't touch this line. There's no other option for it. It has to look like that. But some of you don't get it, doesn't make sense to you, that's okay. Plot, let x be 5, let x be 6, plot some points, and figure it out. That is right, it can't do anything else. And over here, look, these all have to be connected.
even the whole.
The hole is just a skipped point, but the curve goes kind of, it gets to that point, it jumps, and then it goes. The line goes right through there. Yeah, that was pretty easy. All right, let's try one more. We're going to sketch this. We know know the information we have to have in the picture. We have to have all our asymptotes, all our intercepts, and any holes. Alright, so how do you suggest we begin? Factor. No holes. No holes. Everybody okay with that? Everybody see no holes? Even though everything factors, there's no holes because we can't cancel anything, right? Okay? So what? What do I have? I got two vertical asymptotes at 2 and -2. And Jack, they came from where?
Where'd you get
The denominator, because I have this thing called domain, and this rule that I can't have zeros in the denominator, right? So x cannot be -2, and x cannot be +2. So cannot be's are graphed as vertical asymptotes. Alright, what else do I have? A horizontal asymptote where? At 1/2. I have a horizontal asymptote at y equals 1/2. Look. That's not new. We did that a long time ago. Now what about intercepts? Let's get those on there. Where are my intercepts?
you plug in 0.
One, I could plug in 0, and since I didn't cancel anything out, can I just go ahead and plug in 0 here? It will be easier.
Yeah.
If I plug in 0 here, what will I get? Positive 9/8, which is just a little bit bigger than 1. Positive 9/8. You'll get that here too. You'll just have to do some arithmetic. Okay, now I need my x-intercepts. So that's when I let y be 0, right? What's going to happen to the denominator when I let this set y equals 0? What's going to happen to the denominator? It's gone, right? So what about x-intercepts?
I think it'd be 3.
I think it'd be 3 and -3. X-intercepts are called zeros, and they're called zeros because if you plug in those values, you get 0. If you plug in 3 and -3, won't you get 0? That's why they are called zeros, x-intercepts. Now, if I'm grading your paper, my beady little eyes are focused on these things. I don't need to see any other points. I need to see the curve. Can you figure out what this curve looks like based on what you've already plotted, or do you need to plot some extra points?
You might need some extra.
Can you figure out what's going on over here in this side of the picture? Charlie's got it. Right there it is. These reciprocal function things always have these hyperbolas. Now they sometimes have something else too, but you've always got these hyperbola shapes. What's going on over there? Same thing. Any ideas what's going on in the middle? Just a regular parabola. Now, a minute ago when I did one like this, it was a kind of cubic shape. How do I know this one's not a cubic shape? How do I know it doesn't do something like that, squiggle through? It can't cross the axis. It cannot cross the axis between these two asymptotes. So if I know that point's up there, that means they're all up there, right? Can't have any down here. The other one, we had a point here. So when we connected those, it went on down. And that's fine, but this one doesn't have a point there, so we can't do that. But again, Brenton, put in 1 and -1 and see what happens. Go ahead and stick 1 and -1 in and plot those points if you're not sure what that shape is. Plotting points will always work, always. It just takes longer, and often it's not really necessary, because you can think your way through it. Okay? All right, one more. I want you to try this one with your partner, all right? See how far you can get with your partner. All right, I want to sketch it this. Sketch it with your friend. And I will do it too after you've had a chance to get started. I'll put my attendance in right now. Everybody get a whole at 3, 9/2.
Oh, because you got 3.
Wait, would it be 18 divided by 3? Wait, never mind. Should be -1.
Oh, yeah, I factored wrong. Thank you. I factored wrong. That could have been deadly. Thank you. So that makes it 9. Yeah. That was about to just make me cry.
Wait, how'd you get the whole?
Please cancel out something.
Okay.
Did you?
And you have a vertical asymptote at x equals 1. And a horizontal asymptote at y equals 3. Now that is all of the stuff that we already had a quiz and test over long time ago.
Because there's a 3
Now I need my intercepts.
I asked you about it.
I got a Y-intercept down at -9. And I have an X-intercept at -3.
Just -3?
Yeah, there's only one thing left after you do your canceling. There's only one X left in the numerator.
So I have one.
This is all you have left. So when you set that equal to 0, you're solving this. So X has to be -3. That's the only thing X can equal. Alright, so that's what you should have on your paper, something like that. Who has a question?
I didn't even go through something.
How'd you get the
I take my equation and I set it equal to 0. And when you do that, the denominator just disappears. When I solve this for 0, X has to be -3. It's a simple little equation. You just solve it.
I'm talking about the Y-intercept, the 0, 9.
Put 0 in. If I put 0 in for X, I get 3 times 3, which is 9 over -1.
Isn't the X-intercept 0, 3, and 0?
Remember, this is gone. This is gone.
Oh, so you don't
You-
put in the original?
No. Once you do that canceling, everything goes to the new problem then. You cannot have a 0 and a whole. It's one or the other. And the whole trumps because it's a domain issue. Okay? Alright, let's try one more, see if we can get these kinks worked out. Because then I'm gonna blow you away, because it's gonna be something you've never done before. Alright, let's try, oh no, I don't wanna do that. Oh, what the heck, I don't know what this is gonna look like. Let's just give it a shot and see. Actually, I'm gonna change my mind. I'm gonna make this a 6 and this a 4. I'm not ready to do that yet. Alright, so here we go. Alright, see if you can give this one a shot. See what happens. I'll do it too, but I'll give you a minute to get started. Now, we're not freaking out because we don't have a perfect square up top, are we? No, we shouldn't be freaking out. Life is not full of perfect squares. There are lots of numbers in the world that are not perfect squares. Will this thing have any holes in it? Nope. It's gonna have a couple of vertical asymptotes though, isn't it? Jason, this is good stuff. You've been waiting all day for this. Where are my vertical asymptotes? Where are my vertical asymptotes?
At 1 and 2.
At 1 and 2. So I have an asymptote at 1 and I have an asymptote at 2. Eli. Somebody wake him up. Get your head up. Get your head up. It's harder to sleep with your head up. That's your horse. Alright, so I've got two vertical asymptotes. Right? Do I have any horizontal asymptotes? Yeah, where is it? 1.5. Y equals 3/2. So right there it is. Y equals 3/2. No holes. How about a Y-intercept? Is there a Y-intercept? Of course there is. And we'll find the Y-intercept by letting X be 0. And when I put 0 in, it looks like I get -9/2. If I put 0 in, 18/4, 9/2. How about X-intercepts? If you set this thing equal to 0 to get the zeros, what happens to the denominator? So we're going to solve x squared minus 6 equals 0. So x squared equals 6 and x equals? Divide both sides by 3. Come on, you guys. Come on. We're not close your algebra anymore. We're past that. X squared equals 6, so x equals plus or minus root 6, which is 2 point something. So I'm going to have a 0 here and a 0 back here. Now, based on that, can you tell me what the shape is? Now, there's 3 pieces to it. There's this side, there's this little section, and there's this side. So do you know what any of the sides look like? This side's pretty obvious because these points have to be connected, right? So that's what that looks like. Now look over here. You do have a point over here. Does that help you at all? Oh yeah, it does. That's going to look like this, right? Now it's just that middle section that I have an issue with. I don't have any points in there. I don't have any points, including any intercepts, right? So whatever this looks like, it can't cross the axis. Would you agree? Which really boils down then to one shape. It's got to be a parabola. Now what I don't know is it a parabola opening up or is it a parabola opening down? Could it be either one? So what am I going to do? I'm going to plot 1 point. And what do I want to know? If I plug in my 1 point, do I get a positive answer or do I get a negative answer? I don't even really care what I get. I just want to know if it's positive or negative. Does that make sense? So, looking at you got asymptotes at 1 and 2. 1.5. Now, does it have to be 1.5? No, but that's a logical one to try, right? 1.5. And let's see. We don't want to plug it in. Well, let's get our calculators out. It doesn't really matter where I plug it in, so I guess I'll just do it at the beginning. It doesn't matter where I plug it in, Sarah, this time, because nothing canceled. Okay, as long as nothing cancels, plug stuff in wherever you want. Okay, I hope I did that right. I got 22.5. Anybody else get something like that? Anybody else get anything? Michael, this is what frustrates me. You're sitting there doing absolutely nothing. Griffin, where's your calculator? Why aren't you working with us? Because somebody said, well, how do you do that? Well, do it. Then you'll know how we do it. Sarah? Okay, well you're doing something wrong because you should get the same answer both times. So let's do, on our calculators, let's do 3 times 1.5 squared minus 18 equals. What did you get? Negative 11.25. That's my top.
Minus what?
2 times 1.5 squared
18.5.
minus 6 times 1.5 plus 4 equals.
Negative 0.5.
Negative what? Negative 0.5?
Yeah.
So when you divide that by that, you get 22.5. So that's a positive answer. So when I put in 1.5, I got a positive answer, which tells me what about the shape that's in the middle here? It's a parabola opening up. I don't have room for 22 on my thing, so no, it doesn't. I know it's 22, so I know it's up a lot higher. I just didn't have room for it. Okay? Now we're going to do one that's a little bit different. So now we're going to do, on the same page, we're going to do problem 43. We are going to sketch problem 43. Now, what is a little bit different about this guy? Okay, the letter doesn't matter. F of x, h of x, it's all y. So think of it as y. That doesn't change anything. Oh, there's something pretty different here.
Is there a monomial on the bottom?
Well, we've had them with monomials on the bottom before.
Because it's x squared on the top.
It's x squared on the top and only x on the bottom. So what does that mean? It means there's no horizontal asymptote, but there is what we call a slant asymptote or an end behavior asymptote. Both words are fine. In other words, instead of what was the horizontal asymptote being a horizontal line, it's going to be a slanted line. Anytime your power on top is bigger, you know there's no horizontal asymptote, and you're right. But that doesn't mean there's no end behavior asymptote. There is a slant asymptote. Now, how are we going to find it? Well, luckily, you know how. We are going to actually perform the synthetic division represented by that problem. So in other words, we have 1, 2, negative 3, and we're going to divide it by what? Negative 2. So you're just going to do the regular synthetic division, like you always do. Did I do it right?
Yeah.
Okay. And then tell me what the answer is. Remember, that was x squared, right? So this will be x plus 0, and then the remainder of that, right? Your slant asymptote is right here. The remainder, we're going to disregard the remainder. It's why it's an asymptote. It's never going to actually equal that. You always got that little bit of extra remainder there. But this is your slant asymptote, which is a line going through the origin with a slope of 1. So my slant asymptote looks like this. So I do not have a horizontal asymptote. I have a slant asymptote, and it is formed by doing the division. When you have an x squared divided by an x, that's going to leave you with a plain x when you do the division. Now, everything else is the same. Is this guy going to have any holes? No, because the top doesn't factor, so I'm not going to be able to cancel anything. Will it have a vertical asymptote? Yes, it has a vertical asymptote at -2. Does it have a Y-intercept? Yes, and that would be at -3/2. It has X-intercepts. I have to figure out where they are, and I do that how? X-intercepts.
Oh, you plug in.
No, I don't plug, well, I plug in 0 here, right, so I set my equation equal to 0,
Okay.
which means basically I'm solving this equation.
And it does.
You already told me it doesn't factor, so -b plus or minus the square root of b squared minus 4ac. Wait a minute.
It does look like. It does.
Oh, it does factor.
So why wouldn't it?
X plus 3, x minus 1. Oh, good news. Oh, shoot, that's not what that won't change a thing. It just makes it easier for me.
Okay.
X, what was it? X plus 3 minus 1. Now, the reason it doesn't change a thing is I still can't cancel. If I could cancel, then I'd have to do some rethinking. But nothing cancels, so I'm good. And I'm going to have X-intercepts then at -3 and +1. And I would have gotten that from my quadratic formula, right? If I'd have just kept going, I would have gotten that. All right, got my slant asymptote, my vertical asymptotes, all my intercepts. All right, I'm ready to connect the dots. Are you ready to connect the dots? These have to be connected, right? It's still kind of parabola-ish, or hyperbola is a better word probably for it. But it's out here like this, okay. Kind of the same thing over here. Now, you're used to, when we've been graphing these other ones that have horizontal asymptotes, you have them kind of opposite each other usually, right? Are these kind of opposite each other? I mean, you've got a slant thing going on, but aren't these two kind of opposite each other?
Yeah.
And again, if there's one iota of confusion in your mind, then plot some extra points, okay? That's all you have to do. Plot a few extra points. Let's try one more of those. And then we'll take a minute break, and then we'll do something else. Okay. That was 43. I want to do 44. Okay, how do you turn it off? When my mom is in the car, okay, I love my mom. She's fantastic. She's the best mom ever. When I was sick, she took care of me. But when she's in the car, she starts this, I'm one of 6 kids, and she thinks it's wonderful. She's learned how to group text. She thinks it's wonderful. So, anyway, Alright, so x squared minus x minus 2. This is number 44. Alright, so here we go. Now, first thing you notice about this guy is you got a bigger power on the top than you have on the bottom. That means you will not have a horizontal asymptote, right? Now, does anything cancel? Well, this time even I can see the numerator factors. But it doesn't do, I mean, it's good that it factors, it makes my life easier, but nothing cancels. So again, I will have no holes. I can see though from the work I've done that I'll have a vertical asymptote at 3.
Yes.
And I will have intercepts at 2, X-intercepts at 2 and -1. Might as well throw my Y-intercept in there. Where's my Y-intercept going to be? Not -2/3, it'll be at +2/3. Look here, if you put zeros in, don't you get -2 over -3? Which is +2/3. If you put zeros in here, you have -2 over -3. Now I need my slant asymptote. How do I find it? I have to do the division. So here we go. We're going to do the division. In the box goes a 3. And across the top is 1, -1, -2. So here we go. Did I divide right?
Yes.
When we do a slant asymptote, we ignore the remainder. So forget him. What does this represent? 1x plus 2. So that is your asymptote. Y equals x plus 2. It's the quotient part of the division. Just forget the remainder, and it's what else you have. Now that is a line. Starts at 2 and has a slope of 1. So it is going to look like this. That's the line y equals x plus 2. Now part of this picture, I hope after all these examples, part of this picture I hope you got. Cassie?
If it's negative, will it face, will go down?
If the slope is negative, yes.
So it's gonna be like a parabola.
Yeah, this guy, you got all these points in here, and you're going to connect them, and it follows, it's shaped by, think of the asymptotes as like the container, okay? So this is going to get closer to this line and closer to this line, so it's not exactly a parabola, but it's got kind of that shape in there, right? Now, there's another piece to it, though. Any idea where the other piece is? It's right up here in this little section. You are exactly right. So those of you that are saying, I don't know, stop and think. It's got to approach its asymptotes. So it could be out here. But if it were out here, what would eventually have to happen? It would cross the x-axis, and it's not allowed to do that. And eventually it would have to, because that's its container. This is what's guiding it. So it can't be that. If it can't be that, it has to be that. Right? Okay. Stand up, stretch, take a breather. We got about 10 more minutes.
How do you keep, it's just like whatever's
Sure, hurry up.
whatever's set and touch the, like whenever, this section right here, it was, that's it. So you don't want to come like if there's no, like if there's no, I feel like if there's not like the intercepts in that section, then like you can't touch
Okay, those of you that are still in here and focused, we're going to do a little practice quiz. Because the next time I see you, we'll have a quiz. Now, I have your packet stuff ready, but I haven't run it off yet. So, this is a problem out of the packet. It's an old quiz. And we're going to sketch this. All right. Here's your practice quiz right here. I gave this quiz some year. It's in the packet, which I don't have run off yet. This is an old quiz. Here it is. All right, so pretend this is you next time I see you, because you're going to get a quiz problem like this. What are you going to do? Okay, you know you need to try to factor, right? So somebody said group. Now I'm looking at that new, I think that's a great thought. Have that thought in your mind always, but I don't think it's going to work. So what are we going to do? We're going to guess some numbers, and we're going to plug them in, and hopefully they'll give us 0, right? Oh, 1 works. Jason said, look, the number 1 works. Oh, yes, it does. And so I'll go ahead and divide it out. And sure enough, the number 1 works, which means one of my factors is x minus 1.
Isn't the bottom one factor?
Yeah, but I'm not on the bottom yet.
I know.
I'm doing the top.
But that means
Now, what's left after I do my division?
no, or 1
X squared plus 2x minus 8. Does that by any chance factor into x plus 4, x minus 2? Right? Now, Brenton has observed that the denominator factors. And lo and behold, we have a whole. So let's take care of that right now before we do anything else. Let's take care of that whole. So where is the whole going to be? It's going to be where x equals 1. And so I'm going to plug 1 in, and I'll get 5 times negative 1 over 2, negative 5 halves. Did I do that right? I put 1 in. So I'm going to have a whole at 1 comma negative 5 halves. What else can you tell me about my equation? Does it have any asymptotes?
Yeah.
It has a vertical at negative 1.
But no,
It has no horizontal, but it's going to have a slant. We'll find that in a minute. Let's get our intercepts on there. Does it have a Y-intercept?
Oh, yeah.
If you put in zeros, what are you gonna get?
-8.
-8.
If you put in 0, wouldn't you get pot? Oh, yeah.
Now I'm gonna set it equal to 0. What do I get when I set it equal to 0? I get x equal to -4 or x equals 2. Well, I guess I need to do my slant asymptote now. And how am I going to find my slant asymptote? I'm going to do this division right here. But that has to be FOILed out. I can't do it in factored form, so that was this, remember, wasn't it?
Yeah.
So I'll have 1, 2, -8 divided by -1. And remember, I'm not expecting it to be 0. That's not what this is about. I ignore the remainder. What does that tell me about my slant asymptote? It's y equals x plus 1. Which is a line that goes through 1 and has a slope of 1. So it looks like this. That's the line y equals x plus 1. Any idea what the shape is? Remember, all these points have to be connected. So can't you kind of see it here, kids? And coming up here and going out that way? What about the other piece? You always gotta have another piece. You have this point, isn't it kind of doing the same thing? Following this asymptote out this way. Next time I see you, we may warm up with one problem, but then you're on your own to do another, okay? Quiz next time I see you, it's going to be like this. Yeah, just like
Do you always have to have 2 lines? I think so. So if we have
So Michael just asked a very good question. He said, so can I do my 2-6 homework? And the answer is yes. You can do the 2-6 homework. Or at least you should